So now that we have become a kind of expert in solving simple rate problems, I hope by now you have practiced several such problems. We'll move on to slightly more complicated aspect of rate problems and look at questions which involve more than one rate. Okay, so either there is more than one rate, or the number of people who are doing the work has changed, or the time that they have put in actually changes from one case to another in the question. So here is an example. This person is really a slow worker, whereas this lady is really a fast worker. So these two people have different rates of work, and these are the kind of problems we will be dealing with today. Now, even before we start doing this, let us revisit this very simple concept that there is a relationship between rate and the time required for doing 1 unit of work. So if I can do, let us say, half work in a day, so my rate is what? Half work per day. Okay, so this is the concept we looked at in the last time. It might so day might be hours. Okay, so it might be half work per hour. Okay, so whatever it is, this is the unit of time, and this is my unit of work. So at the top I have unit of work, at the bottom I have the unit of time. But if I can do half work per day, then if I ask you how much time would it take me to complete the work, half work I'll do one day, half work I'll do the next day. So the total time required to complete the work would be 2 days. If you notice it closely, what we are actually doing is that we are taking the reciprocal of this half. Okay, we are just inverting it. We are interchanging the numerator and the denominator. Okay, and coming up with this 2 days. 2 days to complete 1 unit of work. So that is what I was saying, that if we take the reciprocal of the rate, then I get the number of days, amount of time required to complete 1 unit of work. So reciprocal of rate. Okay, so we can also arrive at the same thing if we use the unitary method. So let us just look at that for a second. So to complete half work, so I am doing half work, how much time do I need? I need 1 day. To complete one work, how much time would I need? I would multiply both the sides with 2 and I get 2 days. Okay, and this is the unitary method. We have again arrived at the same conclusion, that to complete the 1 unit of work, I can simply take the reciprocal, the amount of time it would take to complete 1 unit of work. To find that out, I can simply take the reciprocal of the rate at which I am doing the work. Now, before we move on, let us just take 1 second to understand what do we mean by 1 unit of work. See, 1 unit of work, it might contain a lot of things. It might mean different things for different questions. So in 1 unit of work, I might say tilling of 1 field, that is 1 unit of work. I might also say that writing 20 pages of homework, solving 100 questions, all of those might be captured inside, might be clubbed inside 1 unit of work, depending on the question, provided that the question is continuously asking me for writing 20 pages, writing 20 pages. Then I club that writing 20 pages as 1 unit of work. I can consider that. So now with this basic understanding, it is very important that you understand this. We can now move on and understand how we solve the problems where 2 different rates are involved. So in the previous class, we discussed this formula, and this applies. This really worked well for us as long as the rate at which the entities involved that was constant across the entities involved. So they were working at the same rate, and this formula really served us well. Now, what happens if I replace one of the robots from my previous class now with this mischievous person who is not so efficient? He is not working as fast as this this robot. Now, obviously, if I have one robot and I then add another mischievous person, so instead of adding another robot, I added mischievous person, my amount of time that is needed will not be halved, right? Because the rate at which this person works is really not the same as the rate at which the robot works. So if the robot works at rate R, this mischievous person works at a rate R dash. It's a different rate. So obviously, by adding this one additional person on top of a single robot, my time would not be halved. How do we calculate the time?